We, as a company, we also develop larger scale commercial and utility scale power plants. So our interest in this is really seeing the market here in California be as large as it can be. But that obviously introduces a number of integration challenges, as we've all been talking about. But sort of just to recap where we are today, the legislature just passed last week the bill to increase our 20% RPS to 33% by 2020, and Governor Brown is expected to sign that bill. And then we have a set of targets that Governor Brown came into office with, which we've heard about already this morning as well, which is a 12 gigawatt target for DG renewables, a 5 gigawatt or so target for CHP, and then an 8 gigawatt target for large-scale renewables. So you take this all together, and it certainly presents challenges. Just to kind of go back to John's quote at the beginning of the session, how do we make this all work together? And that's really the big challenge, because some of this is dispatchable and some of it is variable. Molly mentioned in her comments in the last session that the California ISO has been looking at this issue of integrating renewables, particularly what it would take to go from 20% to 33%. The good news is that their analysis shows that we can do 20% with existing grid resources, but going to 33% would require up to between 4 to 5 gigawatts of gas-like flexible resources. Not necessarily natural gas, but resources, 4 to 5 gigawatts of resources that are flexible and operate as gas would, as a gas system would operate. And so I think the challenge is how do we minimize the cost and the other possible negative impacts of going to a high penetration renewables system, while at the same time maximizing the reliability and flexibility of the systems, or maintaining what the standard of reliability that we've all come to expect in the system. And Brian mentioned a number of possibilities, at least, or variables that are going to come to play on the demand side. You know, it's not just integrating 33% renewables and dealing with the variability of renewable technologies, but it's also adjusting for and accommodating new types of loads like EVs and plug-in hybrids. How to tap into flexible demand on the supply side, how to share supply and supplies and reserves across other utility systems. And Mason this morning talked about we've got to do a better job of that in the western region. And Mark, with his talk about his supergrid world, had the phrase intercontinental dispersion. So how do we actually put a system in place that would take advantage of geographic diversity across the entire country? So the good news is that, again, it's not an issue yet. We can do 20% pretty easily with what we have today. And we have some time to figure this out, but we need to be very proactive in terms of how we move ahead to assess the technologies and how we're going to put this whole system together.
Hi, my name is Richard Flood. I'm the Renewable Energy Development Leader for Johnson Controls, West Region. And we're actually a developer. We don't manufacture any renewable technologies. We are out there basically selecting the best for the customer's needs and installing those. We're unusual in the industry, I think, for two reasons. One is that we work in virtually all of the, at least the major renewable technologies: photovoltaics, solar thermal, wind, and biomass. Second is that we use what we call an IDSM approach, integrated demand-side management. I'm sure most of you are familiar with that, but when we work with customers, we just call it a bundled solution. It's a lot easier for them to understand. So we work mostly with both commercial and with institutional customers. Institutional, of course, being universities, colleges, schools, hospitals, local governments, and state governments in particular, federal government also. And the IDSM concept is that we're going to bring them a whole bundled package. We're going to include energy efficiency, control strategies, demand response, and renewable energy to try to package well, we just know that there's interactive effects when you bring all those things into play. We can actually bring down their energy usage a lot more than if you're doing just any one of those or each of those in sequence. We also plan to be in the energy storage area. Johnson is one of the largest manufacturers of vehicle storage batteries right now, including the first lithium-ion battery plant in the United States, supplying to the Ford Focus Hybrid, I believe it is right now. And a number of us are pushing the company to move to the stationary applications of battery storage as well. So it was for some very informative things here today. And the state of California, by the way, is looking very aggressively, in fact, is accelerating its program for energy storage by at least a year. The hearings, workshops, and so on are being moved up by a full year. One of the interesting things about this interactive effects that I mentioned of IDSM is, one of the problems we run into, I should say, is that the utilities are still incenting each of those areas as a silo. They are now just now starting to look at the notion of an integrated incentive program for integrated solutions. And perhaps one of the issues to be discussed a bit further is the idea of not only taking the incentives, but also investments. We have the very good model up here of everything that has to be done. If we continue to silo our investments, we may not get as good a solution as we would if we were to come up with the best combinations and try to put investment packages around bundled solutions once again. I believe that's my comments.
Speaking of networked.
A little too much connectivity here. Well, thank you all for basically sticking within the time that we have. So we're now, we got a little time for questions. I guess I wanted to maybe start with a couple questions based on some of the last conversation. And it's a line that I recall from Dr. Weinberg, which is, it seems that part of what we're engaged in here is a process of teaching the old dogs new tricks. And with incumbent capitalists, particularly those that are used to what some would call quite astonishing guaranteed rates of return, the market power is a terrible thing for the utilities to waste, and they so far have not really been eager to empower their customers. And I think one of the points that was made about the smart meters is that the value proposition has to be explained to the customer. And just like this chart up here shows a two-way street, the smart grid and the smart meter need to be something that the customer can learn and find out what's in it for them, as opposed to some high-tech device to be spied on by the monopolists. Okay, so the other thing is that we are talking about fundamentally decentralizing a lot of the system in ways that the monopoly doesn't see an advantage to it. Now, our friends at NRDC and others have said, well, we just have to buy them off with these energy efficiency incentives. We're never going to get to do that, I don't think, assuming that even works, with this stuff. You know, it's going to be hard. So how do we get the old dog to learn new tricks, and how do we help them help us make this transition in a way, because ultimately they have a lot of talent, a lot of expertise, and a huge role to play